0, the ball is going positive 30. That's right here. Going up positive 30 meters per second. 1 second later, how fast is it going? Positive 20. But now it's going down by tenths, remember? So positive 20. After 2 seconds, how fast is it going? After 3 seconds, how fast is it going? 0. Where is it on the path now? At this point right here where its velocity is 0. It's at the peak right there. Boop, 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 boop. So this point right up here is point A. This point right here is point B. But now it's going to start going down. When it goes down, it's going to have a negative velocity because it's going in the opposite direction. And following the same trend, the velocity changes by negative 10. What's the velocity going to be after the next second? Negative 10. Negative 20. And then right before the person catches it right here, how fast is it going to be going? So if we draw the line, and this point down here is C. Yes?
And how would you illustrate the person catching it?
Well, when the person catches it, what is their hands going to do to the velocity?
Make it 0.
Make it 0, so then there would be a little right quick drop to 0. But we're not concerned with that little part, okay? All right, now back to our first 2 facts here. Fact number 1, you see this slope right here? What does that slope of the velocity time graph represent? Alexa?
Acceleration.
The acceleration. And if we actually calculated the slope, it would come out to be negative 10 meters per second squared. This is tricky business. Because what is the acceleration on the way up? Say it. Negative 10 meters per second squared. But, keeping the same reference frame, what is the acceleration on the way down? Still negative 10. The acceleration is negative 10 meters per second squared on the way up, and it's negative 10 meters per second squared on the way down. Because remember, to have a negative acceleration, that can mean one of 2 things. It could mean you're slowing down while you're going positive, but what else could it mean? You're speeding up, going in the opposite direction. A very popular trick question, what is the acceleration at the top point, point B? Popular on the exams. Well, take a look. What's the deal with the slope of the line at point B? Careful, I'm not asking you what the velocity is at point B. Barry, what would the velocity be right up here at the top point? 0. Easy peasy. I'm asking you what's the acceleration at that top point, and usually a lot of people get it wrong. Liz? Answer?
Oh, negative 10.
Negative 10 meters per second squared. Were you going to say that, Nishan? Excellent. Even at the top point, when it's still for just a second, the acceleration is negative 10 meters per second squared. Now, fact number 2, area under the curve tells us the total change in displacement. If I find this area right here, here's the x-axis, here's the curve. If I do it 0 to 3 seconds from right in here, and I find this area, we know the area us the total displacement. This time the area is a triangle, so it would be 1/2 base times height. If I'm just doing this little piece right here, it would be 1/2 3 seconds times the height, positive 30 meters per second. 3 times 30 is 90 times 1/2 plus 45 meters. So the total displacement after 3 seconds, 1, 2, 3, right here, is positive 45 meters. Anybody want to tell me what that actually represents?
The ball went 45 meters up.
The ball went 45 meters up from here to here. That's 45 meters. Now, pay close attention here. This next area, I'll do it in green, is below the x-axis. Like that. If I calculate that area, area equals 1/2 base times height, because it's a triangle, 1/2, the base of this little triangle, 3 seconds, because it goes from 3 seconds to 6 seconds. But be very careful, what's the height?
-30.
Took the words right out of my mouth. -30 meters per second. And when you calculate that area, it comes out to be -45 meters. That tells us that the ball dropped downward 45 meters. Yes?
This is like a dumb question, but would you specify which one you wanted us to find? Because if you just said like the curve, I wouldn't know which one. You will? Okay.
Yeah, I'll specify. But remember, if I say the curve, this right here, the graph,
Yeah.
that's the curve.
Yeah.
But I have to specifically say between what times.
Oh, okay, yeah.
Okay?
That's what I meant.
Right. Now, final question. If I asked, what's the total displacement for the whole 6 seconds? And watch me with the ball here. I throw the ball here, I throw it up, and I catch it here. What's the total displacement, Neil, after the whole 6 seconds? 0. Because I started here, ended there. What's the total area under the curve? Whoa. From 0 to 6. If I took the total area, this area up here, and added this area down here, guess what the total area underneath the curve is? 0. So that's what this lesson is all about. These 2 facts. Question?
Can I just fill my water bottle?
Absolutely.
I was going to go to the bathroom.
Sure.